All right, so let's talk about pointers. So first off, let me just declare some variables. Let's say int a equals 5, int b equals 6. And let's say I want to print these out, so I say cout a and l. Let's do the same for b. So when I run this, it just prints out 5 and 6. No surprise there. But let's introduce a new operator. Let's say I do ampersand. And when I run this, what is this? So this is going to be the actual physical location, the actual address of where A and B are stored. So that's pretty interesting, and that's pretty cool. By the way, you might see some C's or some other letters in there. So the reason for that is addresses are stored in hexadecimal. So letter C, I think is, so A is 10, B is 11, C is 12. Anyway, that's a little besides the point. Well, actually, it's going to be pretty useful later, but we're not going to talk about that just yet. Anyway, we have our addresses in memory. So let's actually try and store these places. So we need to introduce another new data type called pointers that are able to store addresses. And again, that's really all they do. Pointers just store addresses. So we have cout star, ints, let's call it AP for just pointer to A. So we're just going to say star AP equals ampersand A. Let's just do that again. A pointer to B is just address of B. And I mean, we could have named these anything. We could have just named these something like C or D. I'm just using BP just to make it super clear. So now, if I were to output these, just copy that. Let's call it AP, BP. So now if I were to run this, I should see the exact same addresses as before. And there we go. This is the same as that. This is the same as that. All right, cool. So pointers would be pretty useless if we couldn't get the addresses out of the values at the addresses out of these. So we need to introduce another new operator. So if I just say, let me just copy these. So I'm going to put a star here and a star here. And the star in this context is going to be called dereferencing. So if I run this out now, I should get 5 and 6, because this is the address where 5 lives. This is the address where A lives, and it just holds 5. So I'm going to say, go to that address and get me the value at that address. So 5 and 6. And I want to emphasize this because this is usually a place of confusion for a lot of people. So when I say int star C, this is going to be a declaration of a pointer. And if I were to put like something like D, that'd be a declaration of an int. So you can have multiple on the same point on the same line. Just if you put star C or star D, that's where you get pointers. But if I were to say dereference C without the int in front of it, this means go to that address and get me that value. So again, that's great and all, but why are pointers really useful in the first place? Why can't I just stick with ints? Because I mean, they're pretty comfortable. So let me introduce a question. Let's say I just wanted to create a function that swaps this value and this value. It's pretty simple. So I declared it up here, but let's just take a look at it. So if you were to swap two variables, you just create a temp variable, assign one variable to the temp variable, overwrite the one that you already stored, and then overwrite the other one with the stored variable. If that doesn't make sense, take a look at this, but this should work. So if I were to try and call this swap one with the variables a and b, if I were to try and print out these variables again, just take this, copy, paste. So now this should print out 6 and then 5. But when we run this, it prints out 5 and 6. So it didn't change the variables. So why is this happening? Well, on a further investigation, if we were to try and do something like this, show me the addresses of the variables a and b in this function. So let's just take a look. 5 and 6. You'll see that our variables a and b here, this is their addresses. But when we call this swap function, the addresses here, these guys, they aren't the same. So this is called pass by value. It means we take the values 5 and 6 and we assign it to new variables here. So the a and b here that we declared here are not the same variables that we declare here. We create new variables in memory. And it's these variables that get swapped, not the ones here. So I can prove that to you. I can say cout a and l. Let's give me b. So right before this, we should get 6 and 5. Right. So how do we fix this? Well, the answer is going to be pointers. So let's say I were to write another function called swap2, and what it's going to do is it's going to pass in the pointers for any two variables. So you might be thinking, well, why does this work? Why does this solve this problem? Well, what we're doing is we're passing the addresses to these guys. And I mean, the addresses aren't going to change. Whenever we dereference those addresses, we're always going to be going to the same place. So let's just try that out. Let me just prove this to you. Let me just get rid of this. Actually, no, we're going to need that. But let's just do swap 2, and I'll explain what it does in just a second. So is this working? No, it's not, because I passed in a and b by itself. We need to pass in the pointers. Okay, so yeah, it works. So let's really look at what's happening here. So we're passing in a pointer, and then we are giving the pointer a. We're going to that address that a holds and giving it to that variable temp. So now we're going to go to the address b and get that value and give it to the address at a. Similarly, we're just going to give the value of a temp to B. So this is something that we actually glazed over before, and I want to emphasize this. Not only can we store addresses in pointers, but when we actually go to those addresses, we're able to manipulate the values of them. We're able to store addresses, and we're able to get the addresses and store them to other variables. So I just want to emphasize this point again. Not only are we able to get the values at pointers, but when we're also able to store values that we point to. So, for example, I'm able to go to the address where A points, get that variable, and store it in an int. Same with B. I'm able to go to the address B and get whatever variable's there, but now I'm able to store whatever variable was in B, and I'm say go to the address A, and whatever was in address B, put in address A. Not only are we able to get values from a pointer, but we're also able to put values into pointers with dereferencing.